Okay, picking up from the last part there. So let's actually do another example where at first glance, it's not obvious that what we want to do is to rationalize our integrand. But as you encounter these, you'll see more and more the value of doing a quick substitution first before you apply one of the techniques that we've developed here. So for our example, we're going to find the integral of e to the 2x over e to the 2x plus 3e to the x plus 2 dx. And this is hard to recognize at first because we're not primed to see expressions with e to the x as having anything to do with polynomials. But here's what we can do. Let's write this as e to the x squared wherever we see e to the 2x. And then we'll see how this is actually a polynomial in terms of e to the x. So as you can see, I've just rewritten it slightly using properties of exponents. But now, if we perform the substitution, u equals e to the x, which remember, as long as there's an e to the x somewhere in there, we'll be able to perform that substitution handily. You'll notice that it might even be helpful to just write this as e to the x times e to the x on the numerator. So just split off the e to the x in the numerator to attach it sort of to the dx, because that's going to form our du. All right, then this can be rewritten as the integral of, remember, there's still a u in the numerator, u over u squared plus 3u plus 2 times e to the x dx, which is just du. Okay, this is a rational function in u, and the denominator we can factor as u plus 1 times u plus 2, which sets us up for partial fraction decomposition, where we have two distinct linear factors. So we're going to solve. We seek capital A and capital B such that u over u plus 1 times u plus 2 equals a over u plus 1 plus b over u plus 2. And this one, see, here's the thing. This one, if you want to solve it quickly, probably our best bet is to use one of those techniques where we plug in the forbidden numbers, right? So this one, the forbidden numbers, u can't be equal to -1, and u can't be equal to -2. But if you convert this into a polynomial equation, this polynomial equation will still be valid at these discontinuities in the original rational equation. And so we're going to apply the two forbidden numbers. So -1 equals a times -1 plus 2 plus b times -1 plus 1, which gives us 0, right? So the only thing left here is the term that doesn't involve the -1. And so that's going to be -1 equals 1 times a, so that's just a. And then if we apply u equals -2, then quite the opposite. The a term is going to go away, and the b term is going to persist. In this case, we get -b equals -2. So our a is actually -1, and our b is +2. Very fun. Then we're going to keep going with our integral. integral equals negative du over u plus 1 plus the integral of 2 du over u plus 2. And in both of these cases, we're going to be able to apply the natural logarithm rule. So negative natural log of u plus 1 in absolute value bars plus 2 natural log of u plus 2 absolute value bars plus c equals, and here's one where I think it might be beneficial even to just combine the logarithms once we get to that point. So remember that a negative sign or any constant in front of a logarithm can be pulled up into the power which means then, and if we're adding them, then really we're multiplying the arguments inside both of the logarithms. So we end up with natural log of absolute value of u plus 2 squared over u plus 1 plus c. And lastly, because u wasn't what we originally started with, it was e to the x, it's actually the natural log of e to the x plus 2 squared over e to the x plus 1. Actually, I don't need parentheses there. Absolute value bars plus c. And that's our answer. So we saw an example with an exponential, but you could very well see an example where you have some fractional power of x. So like x to the 3/2, x to the 1/2. And this technique where we first rationalize it by replacing that and converting it into a rational function will generally allow us to use this technique and apply partial fraction decomposition and come back to the full integral of the original problem. Okay, but that concludes that. The next video or two is actually talking about more general strategies and some critical thinking skills that we need to develop